All right, let's talk about something huge, something that's at the heart of pretty much all data analysis. It's called measurement systems analysis. And really, it all boils down to one simple question. Can you actually trust your data?
I mean, really think about it. You make decisions based on data every single day. We all do. We just assume the numbers are right. But what if they're not? What if the very system you're using to measure things is, well, lying to you? Okay, so when you look at the variation in your process, that classic bell curve you see here, it's not telling you the whole story. See, that total variation is really a mix of two things. First, there's the actual variation in your process, the real differences between parts. But then there's this other hidden part, the variation from your measurement system itself. It's just noise. And our job is to figure out how much of what we're seeing is real and how much is just static. So how are we going to tackle this? Well, we've got a roadmap. We'll start with that hidden problem in the data, get our terms straight with accuracy versus precision, and then break things down even further into repeatability and reproducibility. After that, we'll get into the main event, the Gage R&R study. And finally, the big payoff, how to know if your system is acceptable or not. All right, first things first, let's really get to the heart of this hidden problem and unpack those two sources of variation.
And here it is. This is the fundamental equation you've got to remember. The total variation you see is always a combination of what's really happening, the true process variation, and the noise from your measurement system. And think about this. If that measurement system variation gets too big, it can totally drown out the real signal. You could be blind to what's actually going on in your process.
Okay, to really dig into measurement error, we have to get two key ideas straight: accuracy and precision. Now, I know they sound kind of the same, but they're totally different. The best way to think about it is like target practice. Is your goal to hit the bullseye, or is it just to hit the same spot over and over?
So accuracy, that's all about hitting the target. It's the difference between your average measurement and the true value. Simple enough. But precision, that's about consistency. It's how close your measurements are to each other. You see where this is going, right? You could be super precise, all your shots in a tiny little cluster, but be way off target, which means you're not accurate at all.
And this image just nails it, doesn't it? It shows all four possibilities. Top left, a total mess, not accurate, not precise. Top right, you've got a tight grouping, so that's precise, but it's nowhere near the bullseye, so it's not accurate. Then bottom left, the shots are kind of centered around the target, so it's accurate on average, but they're all over the place, so not precise. And then the holy grail, bottom right. That's what we're all aiming for, both accurate and precise.
Okay, so we're starting to get it. A lack of precision means our shots are scattered. But why are they scattered? What's causing that spread? Well, it actually breaks down into two main culprits: repeatability and reproducibility.
Let's start with repeatability. A good way to think of this is equipment variation. It's the variation you see when just one person measures the same part with the same tool over and over and over again. It's really asking a simple question. Can this one person even get the same answer twice? Yeah, this picture sums it up. You've got one person, one tool, one part. In a perfect world, every single measurement would land on the exact same spot, a single perfect line. But reality isn't like that, right? You always get a little bit of a spread, a distribution of results, and that spread, that's your repeatability error.
All right, so the other piece of the puzzle is reproducibility. And you can think of this one as appraiser variation. This is the variation that pops up when different people measure the same part with the same tool. This is huge. It tells you if your process depends on who's doing the measuring. Is Bob getting a different number than Susan for the exact same thing? If so, you've got a reproducibility problem.
So this all sounds great, but how do we actually put a number on it? How do we measure this stuff? Well, that's where the Gage R&R study comes in. Gage is just a fancy word for your measurement tool. And this study, it's like the go-to diagnostic test to check the health of your entire measurement system. And the process itself is pretty straightforward. You grab a few operators, your measurement takers, and a handful of parts, maybe 10 or so, that cover the typical range of what you make. You make sure your instrument is calibrated. And then here's the key. You have everyone measure every part multiple times, but in a random order. That part's important to prevent any bias from creeping in. Then you just crunch the numbers.
And this is what it can look like in the real world. Now, don't get bogged down in the individual numbers, just look at the layout. See, you've got your different operators, your different parts, and each one is measured a few times. This is the raw data that gets fed into the machine, so to speak, to figure out how much variation is coming from the equipment and how much is coming from the people.
Okay, so the numbers are crunched. Now what? We get to the most important question of all, what does it mean? Is our system good to go, or do we have a serious problem on our hands?
Thankfully, we don't have to guess. There are clear, industry-standard guidelines for this. Basically, if your total measurement variation, your Gage R&R percentage, is under 10%, you're golden. The system's acceptable. If it's between 10 and 30%, it's kind of in a gray area. Might be okay, depends on the situation. But if it's over 30%, whoa, that's a red flag. Your system is unacceptable. It's basically creating more noise than actual information, and you need to fix it like yesterday.
And let's be clear, the stakes couldn't be higher. A bad measurement system isn't just about bad data on a spreadsheet. It leads to terrible decisions. It creates two nightmare scenarios. You start accepting bad parts and shipping them to customers, and you start rejecting good parts, throwing perfectly good products in the scrap bin.
This visual shows exactly what I'm talking about. On one side, the noise in your system makes a bad part look good, so it passes inspection. On the other side, that same noise makes a perfectly good part look bad, so you scrap it. I mean, both of these are just killers for your bottom line and your company's reputation.
So, the next time you're looking at a chart or a report or just a column of numbers, I want you to stop and ask yourself, what am I really looking at? Is this the truth about my process? Or am I just seeing the ghosts in the machine, the shadow of a flawed measurement system? What is your data really telling you?